طيب بسم الله الرحمن الرحيم. So we started to talk last time about the data link control, and the first function of the data link control, as we have discussed before, was the encapsulation or the framing, in which case the data link control sublayer will create or will make the frame by adding the header and the footer and the and also the it will do the framing. And we talked about two types of framing, the bit stuffing and the byte stuffing. So we started to talk about two core functionalities of the data link control, which are the flow control and the error control. As we said last time, this is not the first time we discuss flow control and error control. We have discussed it from the perspective of TCP in the transport layer. So, so the transport layer, it actually performs the flow control if we have a sender and a receiver, and each sender and receiver would have application endpoints. Okay, so in the transport layer, the first thing is that we establish a connection end-to-end between these two application endpoints. And in that case, we have to perform, or at least TCP performs, what we call the flow control, in which case the sender has to regulate the speed of transmitting the segments in such a way that does not overwhelm the receiving app. And then we discussed also error control, in which case we said that the receiving app has to respond with acknowledgement. Okay, this acknowledgement in that case has two purposes. The first one is that on one hand it actually ensures receiving app is coping with speed. In other words, since the receiver is sending a positive acknowledgement, this means that the receiver is able to receive the segments that we are sending it. The second thing is that the segments are delivered successfully. So in which case this is part of error control. So since the receiver is sending a positive acknowledgement, this means that not only is it coping with the speed, but it makes sure, or it sends a confirmation to the sender that the segments have been delivered successfully. So that was the purpose of the acknowledgement. So this flow control and error control are done based on end-to-end. So as we will see, there is a slight difference, a small difference, that in the data link control, what we do is that we perform error control and flow control device to device, because this is part of the data link layer. So in which case, in the transport layer, we have a big network, okay, which is like there are routers in the middle, switches, and so on. So each communication between host and router and switch, and so on, has to go through the data link layer, in which case the data link control will perform also some flow control, but this time based on device-to-device communication, not based on end-to-end application endpoints. So in TCP, we also discussed the congestion control. Can someone remind me of the difference between congestion control and flow control? What is the difference between congestion control and flow control? Yes, Daniel. So flow control is both of them. What do they do to perform a flow? Huh? What does the sender do to perform flow control and congestion control? What does it have to control, yani? The speed of transmission. Okay, so in the flow control, the sender regulates the speed to avoid overwhelming the. Okay, in congestion control, the sender also regulates the speed to avoid ايه بقى؟ Congesting the network. Exactly. Yes. So that's why we did not talk about congestion control in data link control. Why? Because data link control is concerned with device to device. So there's no network in between. Huh? There's no network to congest in between. This is actually device to device communication. It's not end to end. واضح يا شباب؟ So there is a slight difference between flow control in the TCP layer and flow control in the data link layer, as we will see. So so flow control refers to a set of procedures used to restrict the amount of data, restrict the speed of transmission, in order to avoid overwhelming the receiver. So in that case, the sender would wait for acknowledgement, and as we said, the acknowledgement has two purposes. The first purpose is to make sure that the receiver is coping with the speed, since it's sending acknowledgement telling us that it is receiving what we are sending. And also it makes sure that these segments or these frames have been delivered successfully to the receiver. So the acknowledgement is extremely important when it comes to flow control and error control. Error control, on the other side, is the way that we perform automatic repeat requests. And here, the name of the error control in the data link layer is slightly different. We call it automatic repeat request, or ARQ. Automatic here refers to the fact that we detect the error automatically. So we detect the error automatically. How? By the fact that we do not receive the acknowledgement successfully. If we do not receive the acknowledgement within a certain time frame, we will call it a timeout, in which case we will say that, okay, so there is an error. So that's an automatic way of detecting that there was an error. What is my reaction to it is to repeat the same request again. Okay, so that's the concept of automatic repeat request. Or repeat here, it refers to the retransmission of data. Okay, so I have to tell you here that there are 4 possible scenarios of error. Okay, so the first one is that the frame sent. And here, from now on, I will refer to a frame because we're talking about data link layer, okay? So the protocol data unit in the data link layer is called the frame. So the frame sent is lost in the network, or in the link, in the medium. Okay? So even if we have a fiber optics, there is a possibility of error. So in which case, I send a frame on one device, on the other device it doesn't get there, so the frame is lost. The second possibility is that frame arrives in error. Okay, so the frame arrives, but some bits have changed on the way because of noise and so on. 3, go ahead. So the frame is lost, in which case, for example, if we're talking about Ethernet multi-access, there is a collision. So if there is a collision, then all the frames are lost. صح? The frame does not arrive on the other side at all. Okay. In the second possibility or scenario, the frame arrives, but some bits have changed on the way. The third one, frame arrives successfully, but acknowledgement is lost. Okay? So the frame has been sent, arrived successfully, the receiver sent an acknowledgement, and the acknowledgement was lost, again due to collision or any other possibility. Number 4, frame arrives and acknowledgement arrives in error. Okay? So all of these are possibilities to have an error, in which case the only reaction that the sender would do is to retransmit. Okay, so for us, all these 4 possibilities are the same, because my reaction as a sender is the same, is to do retransmission. Okay, but why am I doing this? Because I have to check for each one of them. I have to check that the frame arrives. I have to check that the frame arrives not in error. I have to check that the acknowledgement arrives. I have to check that the acknowledgement arrives not in error. So if the frame does not arrive, or the acknowledgement does not arrive, then I did not receive anything, in which case I will time out. How do I check for number 2 and number 4? Okay, how do I check that the frame arrived in error or the acknowledgement arrived in error? Yes, Hussein. Frame check sequence. برافو عليك. Yes, that's what we have discussed in Network 1, if you remember. So in the frame, we have the header and we have the trailer. The trailer here has what we call frame check sequence, which corresponds to the checksum. Okay, in the IP packet or in the segment, we have to have a checksum. In the data link layer, we call it the frame check sequence. So frame check sequence allows me at the receiver side to check whether the content of the frame has been altered somehow. Okay, I have to say that I said in the announcement of the quiz, just on the side كده, we stop here. We stop at this slide. So slide 11. So this is the mark of this is an important introduction that will allow us to continue the discussion in this chapter of the next quiz. So from now we will start discussing the different protocols for error control and flow control. So I have to say that similar to the transport layer, flow control and error control, they work hand in hand, because both of them are facilitated through the acknowledgement, right? So flow control and error control are combined together, and in the next few slides we will discuss the different scenarios or the different techniques for flow control and error control that are done in the data link control, and we will show you the pseudocode of each one of them. So we'll be able to write a pseudocode for each of these techniques. So these protocols are divided into 2 major categories. The first one is for noiseless channel. For noiseless channel, of course, this is not practical. As we all know, there's no such thing called noiseless channel or perfect channel. As we discussed in the physical layer, we don't have such a channel in practice. But the reason we discuss this is just to start with something simple and then build on it to try to come up with something more and more practical. So for noiseless channel, we assume that the channel is perfect, so we do not have to account for any kind of error. Okay, so all the 4 scenarios that we talked about in the previous slide, they do not happen. They do not happen. So when we send a frame, we know that the frame will arrive successfully to the receiver or to the next device, and there is no possibility of error. Of course, this is a strong assumption, but we want to start with something simple. So here we will discuss the simplest, that this simplest does not even perform flow control. Okay, so it's like UDP. So this simplest is like UDP. So it does no flow control, no error control, nothing. So it just sends all the frames, and it assumes, of course, that there's no possibility of error, so they will arrive to the receiver. Then we will discuss the fact that we need at least to perform flow control. Since we do not do error control because the channel is perfect, at least we will do flow control. So this is stop and wait. Stop and wait is a very famous technique, as we have discussed in the transport layer, which guarantees flow control. How? It guarantees flow control because for each frame that is sent, it has to wait for acknowledgement. And as we said, the acknowledgement here confirms from the receiver side that the receiver is actually receiving what you are sending. So in that case, flow control using stop and wait makes sure that the receiver is coping with the speed at least. Then we will discuss the more practical category of techniques, which tries to account for all the 4 scenarios of error that we talked about, in which case we have to add automatic repeat request to all these techniques. Again, we'll start with the stop and wait, which stop and wait, of course, is the best or conservative technique to guarantee flow control, because anything that you send, you have to wait for acknowledgement. Okay? In which case, you have to make sure that you receive the acknowledgement before you send another frame. You have to. Okay? As we will see that this technique is not efficient when it comes to utilizing the channel. Okay, in which case we need to improve the channel utilization or the medium utilization. So in which case we will discuss the more improvement using go back N and selective repeat. All of them they account the error. So for the case of noiseless channel, we will discuss 2 protocols, as I said. The simplest protocol, which does no flow control, no error control, nothing. And then we will discuss the stop and wait, which at least accounts for flow control. So the way that we will discuss each technique is first through a high-level view like this, which shows us how the sender is designed and how the receiver is designed. At the sender side, we need to look for an event from the network layer. Of course, we are here in the data link layer. So we have to look for an event from the network layer telling us that here is a packet that you need to send, in which case we need to, in the data link control, we need to create or make the frame, okay, by adding the header and the trailer and so on and so forth. And we can then send that frame here across the physical layer. Okay, so at the receiver side, again, we have an event, because the receiver side is acting as a listener. So here we have an event that will tell us that we have something arriving at the physical layer in that case. Okay, so the physical layer will give you the frame, and then what you will do is that you have to extract the data from the frame and then send it up to the network layer. واضح كده؟ So this is So these two here, so this is one event and this is second event. So that's the event here. So at the sender side, you have one event you are waiting for, and at the receiver side, you have one event you are waiting for. And I want you to use these events as a high-level view of what the technique or how the technique actually works. Another thing we pay attention to here is that because this is simplest, the sender is going to keep sending frames, okay, without having to wait for any acknowledgement or anything, in which case the result will be that you have many frames, or possibly many frames on the channel at any point of time, right? Because we don't perform any flow control, in which case these frames are occupying the medium, right? But which is good. It's occupying the medium, so it's good from the medium utilization point of view. But the problem is, it may in fact cause some problems to the receiver, that the receiver it cannot really cope with this speed, right? So this is the problem, that we have many frames on the channel at any point of time. So this is on one hand good for utilizing the medium, but it's not good from the receiver view, because it can overwhelm the receiver. So here is the pseudocode for the sender. So this is the sender side, okay, and this is the pseudocode for that sender side. So here we notice that we have a big loop, right? So the sender is working as a standalone thread or a standalone process that runs all the time, okay, while true. So it's running all the time. However, of course, it's not consuming 100% of the CPU time. So as you all know, maybe you discussed it in operating system or any other course, that a very important fundamental of standalone threads, that it has to have sleep time in between. So in the middle of any algorithm that works in a separate thread, you have to have some sleep time. So this call is the key. So you have to wait for an event, and wait for an event here. Wait for an event from where? Here, from the network layer. So the network layer is going to give you the packet and ask you to deliver this packet as a frame to the other device. So as long as the network layer does not give you a packet, then you are in a sleep mode. So this is a sleep mode until an event happens. So the event here happens asynchronously as an interrupt, as a software interrupt. Okay? So as we all know, the software interrupt happens at any point of time. And in that case, you have to check that this event is a request to send. Request to send is coming from the network layer, that you need to get the actual data, in which case this is the packet that you get from the network layer. So here you have the network layer. Okay. And this is the data link layer, or the data link control. And then you have the file layer. So what happens is that here you have the packet. So the network layer will generate the event and will ask the data link layer to go and get the packet, form the frame by adding this is the header and this is the trailer, okay, and then send the packet across the physical layer to the medium and then to the receiver. So here you have to get the data. So the data link control has to get the data. Then you make the frame by adding the header and trailer. You do bit stuffing, byte stuffing, and so on. and then finally you send the frame to the physical layer. So these are the three things that you have to do. واضح كده يا شباب؟ So get data or get the packet, make frame, send the frame. You don't have to do anything else. You don't have to account for error. You don't have to do any special handling here. This is the simplest. واضح كده؟ So at the receiver side, same thing. You do the mirror operation. Again, you will wait for an event. You sleep until an event happens. And here, in that case, the event comes from the physical layer, that there is a frame that you need to deliver to the network layer. Okay? You make sure that this is the arrival notification of that frame. If that happens, then again, you receive the frame from the physical layer. You extract the data, in which case you have a frame which has a header and a trailer and the data part. So what you do is that you get this data part. This is what is done during the extract data. And then number 3 is to send this data part to the network layer, in which case this data part is the packet, okay, that has the IP header and so on. Okay, so there's nothing special that you need to do here. You need to on the sender side, get the data, make the frame, send the frame. On the receiver side, receive the frame, extract the data, and then deliver the data to the network layer. Any question here, because it's gonna get more and more complicated as we go through these techniques. So in the next slide, we will show you the timing diagram, okay, of this simplest protocol, how it works from the time point of view. So that's how it looks like from the time point of view. As we can see, that this is the sender and this is the receiver, in which case this is time. As we go down this way, this is time. Okay? And of course, this is the space or the medium. Yeah. Okay? So the way that we represent the frame on the medium is by two parallel lines here. So why do we have a thickness here? What does this represent? Why don't we have like just one single line? Why we have like two parallel lines like this? Why there is a frame thickness or a frame length? Remember, this is time. So this represents what? Any idea? عزام عندك فكرة؟ You know what this is? عزام? Okay, fair enough. That's fine. So this is what we refer to as the transmission delay. So this is the time that the sender takes to finish transmitting the frame, okay, until it puts it on the medium. Okay, then what happens is that, as you can see, there is two diagonal lines. Why do we have diagonal lines, not straight? Because here we have another delay. We call it a propagation delay. Okay, so this is the time that once you put the frame as a signal on the transmission medium, that it propagates until it reaches to B. Okay, so that's why we have two parallel lines, and they are diagonal. They are not horizontal like this. They are diagonal. Why? Because you have to spend some time to transmit the frame, and then you spend some time for the frame to propagate all the way to B. واضح كده؟ So the arrow here represents the event. So if you have a request to send from the network layer, then you get the frame and you transmit it. Once you transmit it, it propagates until it goes to B, and in B you have another event, arrival notification. So these are these words here to represent the event at the sender and the event at the receiver. Okay? طيب. Another thing here that we have to pay attention to. Okay? So here we have a specific time interval between these frames. This time interval is controlled by what? The time interval here is controlled by what? Or this event happens how often? How often does this event happen, lower request to send? How often do we have the request to send event? Does it happen every second, every 5 minutes, every hour, or it very ها؟ لا هو there's no specification for how often here, because it comes from the network layer. So every time the network layer has a packet to send, it generates that event, and that's why, as you notice here, it's not fixed. Okay, so between the first frame and the second frame, you have a specific time. Between the second frame and the third frame, you have a different time. So that depends on when the network layer needs to transmit anything. واضح? So in other words, this event happens asynchronously, not synchronized at specific points. Okay, so from this simple graph, we concluded lots of observations that hopefully will allow us to understand the protocol in a good way. Okay, so the problem with the simplest algorithm here is that we send frames without having to wait for anything, in which case here we had lots and lots of frames on the channel, okay, which in fact might cause the receiver to overwhelm, and in that case the receiver cannot cope with the speed. Okay, so that's good from the channel utilization point of view, as I said, but it's not good from the perspective of flow control or overwhelming the receiver. So there is high possibility here that you can overwhelm the receiver. So to solve this problem, we have the stop and wait protocol. The stop and wait protocol here, when the sender sends the request, it has to wait for acknowledgement before it can send another frame. This is very important. So here you have two events on the sender side, and you have only one event on the receiver side. Okay? So again, the events are again the high level macro view of the protocol. So in the sender side, you have two events. When you send a frame, you have to wait for acknowledgement. Okay? And then on the receiver side, once you receive the frame, then you have to process it and then send back the acknowledgement. The acknowledgement, of course, is not an event. The acknowledgement from the receiver point of view is just a procedure that it has to perform, which generates here another event at the sender side. So the result of this is that on the transmission medium, we have only one frame at a time. Okay? The sender cannot send another frame until it makes sure that the first frame has completely arrived to the receiver, in which case it has to wait for the acknowledgement. واضح كده؟ Stop and wait. Again, for this case, there's no ARQ. There's no automatic repeat request because we assume that the channel is noiseless. So we're still in the noiseless channel. We're not accounting for any types of error. Okay, so all the four conditions that we talked about, all the four scenarios that we talked about are not here. So in that case, when we check that the event request to send came from the network layer, we will do the exact same thing. We will get the data, make the frame, send the data, but here the difference is that once we send the frame, we cannot send another frame, even if we receive another request to send. So if we receive another request to send, we have to check here. We have to check this flag. And this flag is by default false once we send the frame, and it does not get set to true until I receive the acknowledgement. Until I receive the acknowledgement here. Okay? So when I get arrival notification, which means that I'm receiving an acknowledgement from the receiver, in which case I will receive that acknowledgement frame, and then I will set the can send to true, which will enable this if statement to be true once we get the event from the network layer. If we get the event from the network layer, but we are still in the state of waiting for the acknowledgement from the receiver, then we cannot send. واضح كده يا شباب؟ So these are the two events at the sender side. At the receiver side, we have still one event, but the change here is that we receive the frame, we extract the data, we deliver. Okay, so that's normal, but the only added thing is that we have to send a frame. What is this frame then? It's the acknowledgement. And we have only one acknowledgement for the frame that we received. We have only one frame, okay, at a time. Okay, so each frame sent, we send the acknowledgement. That's it. Okay, we are sure that we cannot receive multiple frames. That cannot happen. Okay, so we'll start to talk about this in the next techniques. So we cannot receive multiple frames. We only can receive one frame, in which case we send the acknowledgement for that particular frame, and that's it. All right, so any questions so far? So here, the timing diagram for the stop and wait is that we send the request. Once it arrives, we send the acknowledgement. Once it arrives, then we can send another one. So from here to here, it's the round trip time for sending the frame and receiving the acknowledgement, right? So now, as we can notice, the difference between these two consecutive frames is controlled now by two things, not one. It's not only controlled by how often we receive the interrupt from the network layer. It's based on two things: how often we receive the request from the network layer, and how fast we receive the acknowledgement from the receiver. Both. Okay? So as we can see that until we from here until from sending the frame until we receive the acknowledgement, this round trip time, depending on the type of the medium, it might be too long, in which case we have to wait for a very long time, okay, before we can send another frame. And for every round trip time, we can send only one frame. So this is the other conservative approach, or the other extreme. And instead of sending everything, okay, we are waiting for a long time until we make sure that a frame has arrived by receiving the acknowledgement. So stop and wait is very, very conservative in doing the flow control to make sure that any frame that has been sent has been received successfully by waiting for the acknowledgement. So it's not good from the channel utilization point of view, but it's very good from guaranteeing the flow control and not to overwhelm the receiver. واضح كده؟ So the simplest and the stop and wait are two extremes. One does not account for any kind of flow control, and the other one is very conservative in doing flow control. So in both cases, as we said, we did not account for any possibility of error. So until now, we did not account for any possibility of error, which is a strong assumption because all the channel media that we talked about, they have certain possibility of error. They have noise, and they can lose the packet due to collision. So they have some impairments that does not guarantee the delivery of the frames all the time. In which case, we need to account for all the four scenarios that we talked about. A frame does not arrive to the receiver. A frame arrives in error. Acknowledgement does not arrive to the sender. Acknowledgement arrives to the sender but in error. All of these four possibilities have to be checked for. So in that case, we use the automatic repeat request technique to perform error control in combination with flow control. So we'll start with the stop and wait, in which case the stop and wait, as we said, is the extreme conservative approach to guarantee the flow control. But in that case, we need to account for the errors. Okay? And then we will discuss and analyze the problem with stop and wait, in which case we need to talk about go in and selective repeat. So to set up the ground for this, we need to make sure that some fundamentals are clear. So here, this is not error correction. So here, this is error detection because we do not perform correction. So the error detection in stop and wait is done by keeping a copy. So one extra thing we need to do here is that since we need to account for errors, so the first thing we do is that we need to keep a copy of the frame that we are trying to send. Why? Because in case of error, we need to send the same frame again. Yeah, I noticed some people have left all of a sudden. Continue now. So the first thing that we need to talk about when it comes to error control is that one extra thing we have to do is to keep a copy. Keep a copy of the frame that we are trying to send. Why? Because in case of error, I need to send the same frame again. So I have to keep a copy of that frame. It's not that I send it and forget it. No, now I have to keep a copy. The second thing here is that to facilitate the error control, I have to have a timer. Okay, so we need to account for a timer because we cannot afford waiting forever for the acknowledgement to come. Okay, so we have to wait for a certain time, and then we have to assume that one of these four scenarios has happened, in which case we need to retransmit. Okay, so we have to keep a copy. We have to handle a timer, in which case now we have a third event at the sender side. So at the sender side, we have the request to send from the network layer. We have arrival notification from the physical layer to indicate the acknowledgement, and now we have the timer expires event to indicate that I waited for some time and I did not receive the acknowledgement. So we have now 3 events at the sender side. Okay, and of course, in case of error, I need to retransmit. So these are 3 extra work we have to do in order to account for error. We have to keep a copy, handle the timer, in which case we need to start the timer at certain point, we need to stop the timer at certain point, we need to restart the time, we need to handle the timer, manage a timer, which is one extra a variable that we have because of error control. And when we have an error, then we have to retransmit. So the other thing here is that we need to also handle a sequence number. Because of the fact that we have an error or a possibility of error, we have to have a sequence number. Why? Because now let's imagine that we have the sender has sent, this is the receiver. The sender now has sent the frame. Okay, so that's the frame. The frame arrives to the receiver. Okay, of course, the sender has to keep a copy. Then the receiver tries to send an acknowledgement. The acknowledgement was lost. Okay, in that case, the sender would say, oh, okay, time out. I have to send the same frame again, right? But the first frame has already arrived. So the receiver now is actually puzzled. It needs to know whether this incoming frame is in fact the same frame, came twice, or this is a new frame, right? How do we do this? We can only do this if we have a sequence number. So each frame has to have here a sequence number, right? That will tell the receiver whether this is in fact a new frame or it's a duplicate frame that has been received before. So each frame will have a sequence number. So if these 2 frames arrive to the receiver and the sequence number for them is the same, then the receiver will say, oh, duplicate frame, and I'm going to discard that frame. Okay, when I discard the frame, I have to send another acknowledgement. Why? Because there is a possibility that the first acknowledgement has been lost, right? So just the fact that the frame is duplicate, it doesn't mean that I ignore sending the acknowledgement, right? Because in this particular scenario, the reason that the receiver has received duplicate frame is because the first acknowledgement was lost. So in which case, if I receive a duplicate frame, I have to send an acknowledgement because there is a possibility that the first acknowledgement has been lost, right? So I have to be persistent. So the receiver has to be persistent, in which case it has to send the acknowledgement for every single frame it receives, whether this frame is a new frame or it's a duplicate frame. Type. Another thing here we have to pay attention to is that this sequence number is modulo 2 arithmetic. يعني ايه modulo 2 arithmetic? يعني the sequence number goes like this: 0 and then 1 and then 0, and then 1, and then 0, and then 1, and so on. So the first frame will be 0, the second frame will be 1, the third frame will be 0, the fourth frame will be 1, the fifth frame will be 0. So all the odd frames will have 0, and all the even frames will have 1. Okay? So why don't we have 0, 1, 2, 3, 4, 5, 6? You can, but it's not needed. Why? Because here we're talking about stop and wait. The only possibility is that you are distinguishing between two states. There's no third state. The only possibility is that you are distinguishing two states. Either the frame is duplicate or the frame is new. Okay? So if you have two possible states, you can represent the two possible states using binary numbers. 0, 1, 0, 1, 0. Right? We can never have a third state, which means that you have 3 frames at a time going to the receiver. Why? Because this is stop and wait. Remember, in stop and wait, we can only send 1 frame at a time and wait for the acknowledgement. واضح كده يا شباب؟ So we only have 2 possible states. One frame is duplicate and the frame is new. We do not have a third state. Okay? So that's why the sequence number goes in modulo 2. And again, we will generalize this when we talk about go back n and selective repeat, as we will see, and it will become much easier and much more understandable. All right, so here we talked about the 3 extra steps that we need to do. We need to keep a copy, we need to handle a timer, and we need to retransmit in case of error. And the sequence number, which in that case, for the case of stop and wait, it's modulo 2 arithmetic. So it goes 0, 1, 0, 1, 0, 1, and so on. Because we have 2 possible states only. All right, so that's so in stop and wait ARQ, the acknowledgement number always announces the acknowledgement number in the acknowledgement. And here, we have to be aware when you send a frame of sequence number 0. Okay, so I'm sending a frame. This frame is frame 0. Okay, when we send the acknowledgement back from the receiver, what is the sequence number for the acknowledgement? Is it 0? In that case, it's 1. If that frame arrives successfully here, okay, what we do is that the receiver will first increment, okay, from 0 it goes to 1, and then it sends an acknowledgement of sequence number 1. So this acknowledgement indicates that I received everything before 1 correctly, or I received the frame 0 correctly. Send me frame 1. So the acknowledgement number always indicates the expected frame, not the previously received frame. The acknowledgement sequence number always represents the expected frame number, not the successfully delivered frame number. واضح كده يا شباب؟ So these fundamentals are very important. Understand the technique. So here بقى because of the fact that we are talking about stop and wait, the first thing we notice here is that we have only 1 frame at a time on the channel. Okay, we can never have 2 frames, more than 1 frame on the channel at any point of time. Okay, so even for the case of timer timeout, the assumption here is that the first frame is lost, in which case I'm sending another frame. So there is only 1 frame on the channel at any point of time. Okay. The other thing here is that we notice that here we start to have the sequence number to distinguish between the new frames and duplicate frames. And we have this blue one, which is the frame check sequence, right? This is the frame check sequence which will allow us to detect the errors or the changes in the data. So if the frame arrives, okay, but in error, we use the frame check sequence. If the acknowledgement arrives but in error, again we use the frame check sequence in the acknowledgement. Okay? So let's agree on the fact that whenever we have something arriving on the physical layer, the first thing we have to check for is whether this frame or the acknowledgement is corrupted. Okay, by checking that frame check sequence. Anything arrives on the physical layer, we have to make sure we check for errors, or we have to check that this frame or this acknowledgement is corrupted. Type. So we notice here also, we notice here that we have one pointer at the center side which points to the frame that is currently being sent, right? If that frame arrives here, then the receiver will increment its pointer. So Rn, after arrival, it will be 1, and then you will send the acknowledgement back with acknowledgement number 1. Okay? طيب. Another thing we notice here is the fact that now we have a third, so we have 1, 2, and now we have 3 third event, which is the timeout, right? And still here in the acknowledgement we have 1. Okay, so that's also very important. So in addition to the event coming from the network layer for the frame requested to be sent, and the arrival notification from the physical layer for the acknowledgement, we have now the timer that needs to be handled, and when it expires, then I have to retransmit, right? So that's a third event. All right, so let's talk now about the pseudocode. So in addition to the normal procedure that we have done before, now we start to talk about the changes. So the can send here is the flag that we make sure that we receive an acknowledgement before we can send another frame, because this is a stop and wait. So for stop and wait, we always need to use the can send flag to prevent or to prohibit transmission of multiple requests to send frames from the network layer until we receive the acknowledgement for the previous frame. So that's normal. So we've done that before. But what's different now is that first we have to store the frame. Now, the first thing we need to do is to keep a copy. Keep a copy of the frame. Why? Because now there is a possibility of error, in which case we need to do retransmission. So the first thing that we have to keep a copy, right? So that's number one as an extra step. So in addition to get data, make frame, we have to keep a copy. Number two, as we said, we have to handle the timer. So with every frame to be transmitted, we have to start the timer, because we cannot wait forever. Okay. Number three, we have to handle the sequence number, and this is modulo 2 arithmetic addition. Okay. So in other words, this is XOR. So when we have 0 plus 1 is 1, 1 plus 1 is 0, right? And then 0, and then 1, and then 0, and then 1, and so on, right? So once we send the data, so let's assume that the first frame was 0. So now SN is already incremented. So SN let's say that this is frame 0. So Sn was here, right? So now Sn has moved to here. Okay, so once we send the frame, Sn is already incremented. So this is the first event, the request to send. Let's see the second event, which is the arrival notification. Is pointing now at 1, as I said. Sn has moved from 0 to 1. Incremented here. The Sn has already been incremented here. So the one that was sent is the one before me. So the one that I acknowledgement, right? As I said, rule of thumb, anything we receive from the physical layer, we have to check for errors. We have to check for errors, right? So we have to check that this acknowledgement is not corrupted and the acknowledgement number equals to Sn. As we said, if the frame that I sent is 0, the acknowledgement should be 1, right? So the acknowledgement should be 1, and that's what Sn is for, Sn, right? So if the acknowledgement is not corrupted and the acknowledgement is Sn, that's only when I will accept this acknowledgement. Okay, so accept this acknowledgement. This means that okay, خلاص. So now I have to stop the timer, because when I send, I will have to start the timer again. This purge is equivalent to the keep copy. Once I send the frame and receive the acknowledgement, now I don't have to keep a copy anymore, which means I purge. And notice here, purge n-1, right? Because the Sn has already purged is frame 0, right? So that's why we have the sequence number -1 here. Okay. And since I received an acknowledgement correctly, now I have to set the flag cancel. The other possibility is that I wait forever and I cannot receive the acknowledgement, either because the acknowledgement has been received but corrupted, or because the acknowledgement has not been received at all, because it's lost or it's delayed. There are many possibilities. So in which case, I will wait until the timeout happens, in which case, all I need to do is just to start the timer and resend. And again, resend here, I resend the previous one, because already the Sn is pointing to frame 1 already. So I have to go back to the previous one and send it. So this is the retransmission. Okay, so these are the 3 events from the sender side. Receiver side, the only thing I need to account for is that, okay, since there is a possibility of error and I have something arriving from the physical layer, then I have to make sure that it's not corrupted. If it's corrupted, then I will not accept it. I will go back to sleep and خلاص, I will ignore it, right? The other thing is that if I receive a frame and the frame is was the one before it, okay, if the frame sequence number is not Rn, this means that this frame is duplicate. I cannot accept it. So I only accept the one that has a sequence number equals to Rn. Okay, this is the receiver pointer Rn. So I have to make sure that the sequence number for the frame that's arriving is identical to the Rn. In that case, I will extract the data and I will deliver it up, right? And then I will move Rn to the next frame. If not, or if in both cases, I have to send the acknowledgement. And as I said, we have to send the acknowledgement even if it's a duplicate frame. Why? Because again, this may indicate that the previous frame that I sent before was lost, so I have to send the acknowledgement again. So this is the acknowledgement, and this is part of being persistent. So this is persistent receiver. Okay? So either the frame arrives duplicate or the frame arrives as new. In both cases, I have to send an acknowledgement. So anything I receive from the sender, I have to send an acknowledgement. Okay? Any question, Shabab, about this? So now, in case of the timing diagram, I have multiple cases. So the first case is the happy path. So here, remember, Sn is pointing to frame 0, and Rn was initially 0 until it receives frame 0. When it receives frame 0, it will move to 1. Okay. Once it moves to 1, this one is going to be set as the sequence number for the acknowledgement. So when this arrives here, when I have this arrival here, this Sn will be already has been incremented, right? So now I can send frame 1. So now if frame 1 is lost, then the receiver will not receive anything, so there is no arrival here. So the arrival did not happen, in which case I did not receive an acknowledgement. So in that case, I will have the timeout event. The timeout event here will allow me to resend frame 1 again. Actually here, المفروض هنا ده هنا SN. SN already is incremented after sending the frame 1. Okay, so if the receiver receives that frame and sends the acknowledgement for acknowledgement 0, then the acknowledgement arrives and SN is already at 0, so it will accept it, arrival okay, stop the timer, and then I can send the next frame, which is frame 0. So as you can see here, this acknowledgement number always coincides with the next frame. So I received all the frames before correctly, send me frame 0. So I will send you frame 0. So this is the one that to be expected, not the one before, because the one before has already been received successfully. So now the other possibility is that when you send an acknowledgement and the acknowledgement is lost, so again the timeout will happen, and here the only difference is that I will have the duplicate frame. So duplicate frame here, the frame will be ignored, but very important, the acknowledgement will be sent again. And now the acknowledgement here is the same like here. The acknowledgement is the same. Why? Because this may indicate that the first acknowledgement may have been lost, in which case I have to send the acknowledgement again. That's part of being persistent. Okay? So either I send the frame and the frame is lost, or I send the frame and the acknowledgement was lost. To me, it's the same. I have to retransmit. That's from the sender point of view. From the receiver point of view, I have to detect the duplicate frame, but again, in both cases, I have to send the acknowledgement. Very importantly, Basharab, very important here, we notice the big motivation for the technique coming next is that here we have this time, this whole time is a time to wait, right? So the time from here to here, it's the time for the round trip for the frame to go all the way to the receiver, and then the acknowledgement comes back. This is what we call the round trip time. So during this round trip time, فعليا, actively, all I have sent is one frame. What I have sent is only one frame, right? So how can we evaluate the medium utilization for the stop and wait? All right. So the last thing we have to bear in mind here is that, so we go back to the concept of bandwidth delay product, and as we said before, bandwidth delay product measures the amount of bits that can fill the line during a specific time. Okay, the amount of bits that can fill the line during a specific time. So if if we assume that we have a medium, okay, that has a thickness or bandwidth 1 megabits per second. If we assume that for one bit to go all the way to the medium and then come back, the first one is actually the frame, the second one is actually the acknowledgement, right? So this round trip time is actually is 20 millisecond. 20 millisecond is significant. This means that this medium is very big. So assuming that the round trip time is 20 millisecond, the bandwidth delay product in that case is 20,000 bits, which means that I can fill this line with 20,000 bits during the 20 millisecond time, which means that all of these can be frames that can fill the line. فعليا بقى actively, what I have sent during the stop and wait is only 1,000 bits of frame. And I have to wait for the whole round trip time before I can send another frame, right? So actively, I have engaged with the transmission to send only 1,000 bits. So the actual utilization of the channel, I have sent 1,000 bits and I could have sent 20,000 bits, right? So I have sent 1,000 bits out of the 20,000 bits that I can send during the 20 millisecond transmission time or round trip time. So as you can see, the utilization of the channel is extremely low. In fact, it's actually 1,000 divided by 20,000, which is only 0.05, or in other words, 5%. So I have utilized only 5% of the whole capabilities of the medium, or the whole bandwidth of the medium. So in which case, stop and wait, it works. It's very conservative. However, the main drawback is that the channel utilization for stop and wait is very, very bad. So that's why the solution, if we imagine that without, we ignore about stop and wait and we send 15 frames. If we send 15 frames, then we have 15 times 1,000 frame over the 20,000. So in which case we can have up to 75% utilization for the channel. So we have improved. But again, stop and wait cannot do that, because stop and wait can send only one frame at a time. So that's why we need another technique that will allow me to send multiple frames without having to wait for acknowledgement. Such a technique is different from stop and wait, and that's what we need to discuss next time, inshallah. Right?